Okay, this one just arrived, and it's a 1941 arts and crafts house. One of the things that distinguishes this is the height, obviously. On wheels, this thing is built pretty close to 30 feet high, so these buildings are really not deliverable everywhere. They are generally deliverable to waterfront or semi-waterfront properties, but a very, this is would be considered a custom house, and like a classic piece, more or less.
Excellent.
2,000 square feet.
And what about this one here, Jim?
Okay, that one next door, that's also a craftsman-style bungalow, although you can barely see it from the outside because it's unusual. A lot of the craftsman-style houses are wood-sided and so on. This is a colonial style, so the interior of this building is cabinetry. It's very finished, high grade, and it's about 1,300 square feet. This building here is about 35 feet wide, and it's low enough to be deliverable anywhere. Most buildings are deliverable, relatively easy to deliver if they're under 18.6 and they're no wider than about 35 feet. From 30 to 35, most of the time the buildings are deliverable. Once you get between 35 to 40 feet, the difficulties of delivery increase. So this would be a readily deliverable building. Next, we've got a early 50s bungalow, very high construction standard, but this is quite a simple, affordable family home. Very basic goods, but very, very well built. Same thing with the one next door. It's just a really affordable bungalow, and a fairly simple building. Not really much that defines it, other than that someone has spent a lot of money on the interior, and it was worthy for moving for that in that regard. Here we've got, this is a real bona fide craftsman-style bungalow, California craftsman-style bungalow. The reason it's got a flat roof is because these buildings, as we described in the first one, they're always too high to move. So what we have to do is we have to turn this into road food, and we do that by taking the roof down. This building is now effectively deliverable to most locations. And what needs to happen at the other end is usually what they do is they lay out trusses and put plywood on it, put a new roof on it when they get it there. We put a temporary travel roof on this, so it's sheeted with plywood, and then there's a roll-on Duroid roof, torch-down Duroid roof on top of that, which makes this building rainproof and protects it while we're looking for an alternative location.
And what happens to the basements?
The buildings are always lifted from the floor joists up. So the basements, bear in mind, the lower walls are sitting on concrete. When we lift the building, those lower walls are torn off. And everything is basically tucked up into the floor joists in terms of the electrical systems. They get rolled up. The electrical panels get folded up underneath because they're usually in the basements. But most of the actual bulk of the building is from the floor joist up is really where most buildings have all of the infrastructure and the floor plan and so on.
And what happens to the heating systems?
They're all different. Usually anything that's functional with the building, hot water tanks, furnaces, and so on, are put up inside the buildings. We have prep crews that go in and strip out all of the elements and put them up in the buildings. Most of these buildings have forced air systems. A lot of the tin work below is removed because generally they're older and it's nicer to install newer stuff anyway, but the actual furnaces and hot water tanks and so on are up in the buildings. Some of them are electric heat as well, so everyone's a little different. That one is water radiant heat, so everyone's slightly different, but that's usually what the infrastructure stuff looks like.
What happened to the wall on this one?
Okay, that building is what we refer to as a building section. So that building is in two pieces. The other piece is over on the other side, over behind us. These buildings are buildings that are usually L-shaped, or they're too wide to move down the road. So what we do is we actually section them. As long as you cut it the way it's built, so you're cutting with everything, then they're quite simple to move in sections, and then we kick them back together when they come onto the new properties.
And does that cost a lot more for the owner?
These are generally higher end buildings, and what we have to determine from the beginning is that they have the value to do this with, because obviously it's the same as moving two buildings, even a little more so, because we have to section them and kick them apart. So they have to be high grade value buildings in order to warrant this kind of costing on them. So these are generally higher end buildings.
So Jim, how come there's still brick on this entranceway of this house?
Yeah, well, generally speaking, masonry does not move. Chimneys always come down on moved buildings. In this case, this would be a cosmetic feature. and there was a slab underneath it which was supported by floor joists, so it was actually effectively moved. But generally speaking, masonry stays behind because old bricks don't move that well.
And are most of these houses updated, or do we need to update them once we move them to a new property?
Yeah, everyone is a little different. For the most part, a lot of them are upgraded because they're part of the renovation generation, so people have improved them. Example, I mean here, this one has had blown-in insulation in the walls. It's had the windows rebuilt on it. But the wiring on this one is older 2-wire system, and you really need 3-wire. So this one is up to scratch except for the electrical systems. Most of them, the electrical systems are acceptable. Everyone is different. So yeah, it's just a case-by-case basis. The chimneys have been removed in this building, but the facing stays with the actual framing. And what people do with these nowadays is very, very seldom do they go back with masonry. They usually go back with an insert now. So this is a galvanized box that contains an airtight and a fireplace that goes in, and then it's stainless steel, and they dummy it up above the rafters. It's much cheaper than doing a masonry chimney, and it's a lot quicker. But so that's really how they deal with this kind of.
Jim, what happens with the plumbing?
Okay, plumbing with the houses, most of the plumbing is copper in these buildings and cast. So the plumbing itself is integrated and stays with the building. You know, there are the occasional repairs because if the copper lines are in the way of the steel, they will cut it. But generally speaking, the buildings are complete plumbing-wise. As far as a moved building, this building is now up on steel, and as you can see, there's relatively minor cracking. Usually what happens is you'll get these cracks here, for example, on the ceiling. These are original that would have been there with the building prior to moving, and they expand and contract on existing cracks some of the time. This is really true of the older buildings, which are lath and plaster buildings. The newer ones, which are drywall buildings or hardboard buildings, which is hardboard with a plaster over top of it, a drywall with a plaster over top of it, there's less cracking. This building has really minor cracking for a building of this scale, and it gives you some indication of what a piece of construction it really is, the standard of it. Also, this is a fairly narrow building. The wider the building, the more there's a chance for more deflection, and you can have a little bit more cracking. Once again, it's relatively minor. Usually with these ones, what they do is once the building is lowered onto the foundation, everything sits flat. Then you take a can opener and open up these cracks a bit and just trowel non-expanding drywall mud back in to fix them up, and otherwise drywall tape and mud to repair the other areas. But the cracking itself is relatively minor on most of these moved buildings. As you can see, there's very little. You know, we've got a bit of force on this center wall because these ones hang out in space. They cantilever, and the weight transfers back and pushes up on these center walls. But a lot of this stuff is just shifting where it was originally cracked. But this one's actually, so a lot of these buildings, once again, they're mixed bags in terms of insulation. This is an older building. There's usually insulation in the actual ceiling and in the crawl space. This is blown wool insulation. But the other thing is that if there is not insulation, it's relatively inexpensive to blow it in through the walls. What they do is they drill holes up high on the wall, and they blow it under pressure inside the wall, and it's really quite effective. And so that's how you get the R factor for these older buildings.